Okay, today we're going to look at the solution to the 2014 higher level question 6 that we did as an exam last week. So what we have is the figure shows a logo for an animal shelter. The curve ABC is a parabola with its vertex at B. The curve DEF and GHF are identical to the portions of the same parabolas with vertices at E and H respectively. The curve JKLM is an ellipse with the focal points at N and P. Draw the given design showing clearly all constructions. Okay, so for the first thing that we're going to do with this is we're going to draw in the parabola ABC. Once we've that complete, we're going to finish drawing the pause. Then we're going to look at locating the 60-degree line that will locate the axis of our ellipse. Once we've that done, we'll look at locating the actual length of the major axis of the ellipse, because we're not given the measurement. We're only given the location of the two focal points, and we are given the measurement of the minor axis. From there, we look at locating the points on the ellipse. We'll draw on the curve. Then we'll come back down and look at the parabola DEF. Okay? So, step one, we're going to use the rectangle method for drawing in the parabola. The width of the base of the parabola is 140 millimeters. So we're going to divide that line up into two. So make our marks at 70 and 140 to locate the parabola. The height of the parabola is 110, so we'll draw in a rectangle at 110. Okay, we're going to use the division of lines to find the points for our parabola. So on the left hand side, I am going to divide this portion of the rectangle up into 5 equal sections, and this portion up into 5 equal sections. So I've drawn my line out at any angle, and I'm going to use 20 millimeter divisions on my line. I'm then going to draw the last point back to the top corner of the rectangle. And using my set squares, I can draw the line parallel. Okay, I'm now going to divide the bottom up in the same method. This time I'm going to use 10 millimeter divisions as it's a little bit smaller. Okay, so my divisions at the side can be drawn up to my vertex at B. Again, these are all construction lines, so keep them light. I'm now going to draw my vertical lines up to match them. My points in the parabola are the following: 1, 2, 3, 4. I can now draw in that parabola. Now, I'm only going to draw it in light for the time being until we get towards the end, and I'll fill it in heavy then. Now, in order to find the second part of the parabola, I can simply translate each one of my points across. Using my compass on center axis, I can swing my points across. Now draw in the second part of my parabola. Again, I'm going to keep it light as it's only construction stage yet. Step 2, I'm going to locate the pause at the bottom of the parabola. The radius for them is 25 millimeters. 1 is located at the edge of the rectangle, so let me draw that in heavy. Part 2, the center point is located 12 millimeters in from the edge. I can now draw my baseline in heavy as I know the location. Step 2, I'm going to start to locate the center axis for the ellipse. The question tells me it's orientated at 60 degrees from the edge of the circle in the pole. So I'm going to draw my line in at 60 degrees very lightly. The question shows us that the major axis, or the minor axis, is located at point M, which is 20 millimeters down from the vertex at B. Measure down 20. And I can mark my point. So point M. The minor axis center point is located 20 millimeters away. Using my set square, I can draw my line in at 60 degrees to find the center axis of our ellipse. I can now draw in the minor circle, which is radius 50 millimeters. The question does not give me the radius of the major circle. However, it does tell me where the location of the two focal points are. The question shows me that the two focal points are measured out 25 plus 37 at N and P. I'll measure out 62 millimeters on both sides, and that gives me my focal points N and P. Normally, when we are given the major axis and minor axis of the ellipse, we are not given the focal points. And to determine the location of the focal points, we take half the length of the major axis and swing it from the top of the minor axis to cross the center axis, and that gives us our focal points. We can now use that in reverse. So we can take the distance from our focal point to the minor axis. So from point N to point M. that measurement on my compass is now half the length of my major axis. So I can place that down on my centre and draw in my major circle. I can now start drawing in the ellipse. So locating my points is quite simple. Using the same method, the concentric circles, I can find the points on the ellipse. The only difference about this ellipse here is that it's orientated at 60 degrees, so it might just confuse you a little bit. As long as you remember what line is your center axis, you should be able to draw it in, no problem. I can now fill in part of the parabola that is heavy. What I'm going to deal with next is locating the parabola DEF. Section DEF. The height of this parabola is the same as the vertex for ABC. So I can simply bring my vertex B across. Point E is located 45 millimeters further out. So I locate my vertex for my parabola. Now I can simply take my points from the parabola ABC and bring them across to my vertex. Using my compass, I'm going to take my measurements from my center vertex of ABC out to each one of the points. I'm then going to bring my compass over to where the point crosses my vertex for the parabola DEF. I can now draw in that portion of the curve.